Okay, hello everyone. Please let me know if it actually works. It should work, however. I did stream yesterday, and yesterday everything worked. No, was it Monday? I think it was Monday. So it should work as well. So hello, good evening, and it's been a while. As you've seen, I'm kinda restarting my YouTube activity. There are some videos which are showing up, and also I did a webinar on Monday, though it was on a different YouTube channel. And yeah, and today is a live stream, so it's going to probably be a short one because yeah, like restarting, so I'm taking it slow, checking if all my scripts and everything else actually works, and it seems it's not going so bad. So yeah, let's go. Cool. So what are we going to do today? We are going to go through a couple of usual stuff. First of all, paged out is out. In case you don't know what paged out is, then it's this free magazine, pre-zine basically, about everything technical which I like. Or rather, not yet everything technical which I like yet, because there are still a couple of gaps in the topics we are covering, but I'm kind of working on that. So you can just like go to the Paged Out Institute. I'm going to share, already shared on the chat. Thank you to my moderators. Today my moderators are Foxtrot Charlie and Asha. And yeah, so just go to the website, click on the PDF and you can read it. That's it. Like no registration required or anything. It has 80 pages, this one, and it's actually really cool. Like this is, I think, the best issue we had so far. If you haven't read Paged Out yet, basically every article is one page, just one page, so they are pretty fast to write, pretty fast to read, and they are technical, like everything is technical, it's like programming, hacking, hardware, and so forth, and so on. So we also have wallpapers actually, so if you like the cover, then you will also like the wallpaper. Let me show it maybe. This is the... Oh, but it's not full screen. I want it full screen. Yeah, now this is the wallpaper, which is made by an artist who also created the cover. We usually do them in pairs, as in we order both the cover from the artist and the wallpaper. And yes, this is not AI. This is actually human drawn. We actually provide some feedback during the process of creation, so we see, you know, all the concept arts and all the stages while it's being drawn. So yeah, this is verified human content, which I guess is something you have to say now in 2025, since it's not really that obvious anymore. And we have all like all our wallpapers are basically made by humans, and every issue, we have 6 issues so far, has a wallpaper which is accompanying it. Like for example the one I have in the background. So there we go. So that's one thing. And the second thing, actually, I guess I should mention that Temp Out also came out a few days ago. So Temp Out, which is not related to Paged Out, though we do like them very much. It's a really cool design. So a few days ago, also volume 4 of Temp Out came out, and it's, as you can see, like it looks a little bit like these BBSs from the 80s, from the 90s, and it's really cool. I really like the layout. And it focuses on like elves and Linux and like low-level stuff, basically. There's also my article here, actually. So that's, I guess, something I can also link you on the... Oh yeah, perfect. I guess I should leave linking to my moderators. They are amazing at it. Yeah, there's also my article here with like a fixed SLR. It's basically about a task I created for Google CTF. And I kind of split the roles in this article. There's like there are sections from the player perspective and sections from a creator's perspective. And they like basically interweave with each other. So you get a little bit of what the player saw and a little bit of an explanation why was it designed in this specific way? What did I want to achieve as a creator by designing this like this piece in a certain way? What were the dangers which I was trying to avoid, not to make the challenge too hard, not to run into any problems like maybe too complicated code, which I'm not really sure about that it works, and that might create unintentional solutions, which are really cool on CTFs, but as a creator, well, they are unintentional. It's in the name, so it's not your intention that they are there. Yeah, it's a pretty long article, actually. And if you're wondering how to write such articles, as in like, because the layout is pretty complicated even for ASCII, right? And we have this like Unicode art here on the left. You actually write them in Google Docs, and then you create a Python script which lays out everything. So you export in Google Docs to HTML, and then you use beautiful soup in Python, and you start like write your own layouting engine which does this. I'm pretty happy with this the outcome, actually. Okay, so let's get to the main topic today, which is so yeah, I have this like new educational website which I'm slowly filling with content. Not only like there are like several people working on this, and there are some articles here, but there are also exercises which I wanted to look at. We were finally able, or rather I was finally able to do something with the website which I wanted to do for years now, and that is to have a nice place for my old CTF challenges. Like, because in the last decade or so, I've made a lot of CTF challenges, both for like Dragon CTF, made by Dragon Sector, or like other CTFs under, well, made by Dragon Sector, not under the Dragon CTF name, for example, Confidence CTF, but also for Google CTF, which I also contributed a lot of challenges there. So currently there are just a couple of challenges, and I have to thank Dejan, who is actually responsible for putting them on hackArcana. And all the challenges are reflagged, which kind of means that, oh, if you actually have the flag, or like find the flag in some write-up, it doesn't work. Yes, you can use the write-up to step-by-step solve the challenge. And that's cool, because this is an educational website, so yeah, more power to you, basically. But you do have to still go through the motions, basically. And in case of a task I wanted to chat about today, which is Gamepad, I wanted to go through it because to reflag this task, we actually, or rather Dejan actually had to basically recreate it, or rather recreate half of it, which you will see soon. Anyway, so about the site, and I guess this is like advertisement because technically it is a commercial site. So I'm pretty sure we have on YouTube marked somewhere that yeah, this stream contains advertisement. And anyway, but it contains also cool CTF challenges. If you want to solve some stuff, we have, again, like just go here. It's free. Like the content which we at this point have on the website is mostly free. We have one sign up to my commercial training, which is upcoming next week. Actually, I'm going to talk a little bit about it later. If you solve a challenge, you get a flag. If you get a flag, you put it here, and then you are on the scoreboard. You know, typical wargaming site. We have more users than last I checked. Cool. Let's get to the exercise. Everything else doesn't matter. Only exercises and CTF challenges matter. So what is this exercise about? Let's read the description. The description is, here is a recording of a flag being entered into the Gamepad HTML5 application. And notes the flag format is hexa with, so not Dragon as it was before, or rather the RGNS. Now it's hexa. There's a file to download, which I'm going to download. As you can see, I already downloaded it actually. And there's just like info that, yeah, this challenge was created for Dragon CTF. It's actually an archival challenge put here because it's kind of sad that like CTF challenges have this short lifespan, right? That you make a challenge, it goes live on a CTF, and then everyone forgets about it. So it's thankfully it has like a second life on this platform. Okay, so inside the zip file, after extracting it, we have two files. We have Gamepad HTML, and we have this backup ng, which is a Wireshark file. Well, it isn't technically a Wireshark file, right? It's just like a file, binary file, which honestly is just a list of packets, and these are USB packets. So basically what happens is that you connect, or rather somebody connected a gamepad, and I have only this as a prop, but actually this wasn't this kind of gamepad. It was from a certain console. We have to figure that one out. So yeah, there was this gamepad which was connected to a computer using a cable, and the USB traffic was hijacked. So we have a USB traffic of somebody operating a gamepad. But what were they doing on this gamepad? And this is where the second file actually comes in. And the second file is, let's quickly look at it here. It's not really a challenge. It's just like an on-screen keyboard, which looks like this. So if I have a gamepad connected, then I can like move between these letters with a gamepad. And yeah, and then I can click to select a letter, and then it will appear here. So somebody basically used the gamepad to move through this website, select a letter, and enter it as the flag. And after doing this, yeah, like that's it, basically. This is what they done. And we need to figure out what was the flag which they entered using this the gamepad. So, okay, what do we do now? Well, we have to figure out what kind of a gamepad is it, and what does the how does the website actually interact with the gamepad? If I would have a gamepad connected to the website, then that would be easy because I can just play with it. But because I don't have it connected, and some players might have a gamepad, others might not. Let's do it the hard way without a gamepad. So let's just look at the code of a website and see what does the JavaScript actually want here from the gamepad. And is this stream saved? Yeah. All my archival streams are saved on this channel. Is this an RE challenge? It is an RE challenge, but not reverse code engineering. This is reverse data engineering. As in, I guess you can think about it more in normally it would be in the forensics category. If there's a forensics category or a MISC category, it would be put there rather than in the RE category, because the RE category on CTFs is usually reverse code engineering. That being said, well, we are going to look at some JavaScript, and this is technically reverse code engineering, even though it's in JavaScript. So let's see what's going on here. We have we have this script. How long is this script? It's not very long, and it's actually pretty readable, thankfully. We have, I think everything we need to know is already here. We have the direction buttons, and the direction buttons are like not the joysticks here. These are like this little thing here. This is the D-pad, and also known as direction pad, I guess. And these are the direction buttons. So you have only the directions buttons are being used, which is cool because the joystick is actually, it knows how much did you actually shift it one direction or the other, which means you might get values as like it was moved by 0.1 unit or like 0.8 units, right? But which is like would be a little bit of a mess to try to figure that out. But thankfully the direction buttons are buttons, which means you press them, and if you press once, it's pressed once, which isn't fully true, and we will get to that later. And there are like two buttons used, the X button and the A button, according to the to this. I'm not sure if there's an X button and A button on the actual gamepad which was used to reflag this, but on the original, yeah, there were these buttons. And this is, I guess, called reset and select here. So yeah, I guess like we know everything now. We just move the cursor, this red thing here, with the direction pad. So if we press right, for example, then it moves right. And then when we press select, which is, I guess, it's marked as A here, but that might not be true, then a character is selected for the flag. Now, what we saw here also is something called debounce. If you don't know what's debounce, that's when you press a button, it's like this. Like think of a cross section of a button, right? So you have the pad here, and the button is sticking out a little bit, right? Let's assume this is the button, and then you press it, right? So it goes down, and then, well, it's obviously pressed, and then you release it, and it goes up. Well, this is how it looks like from our perspective. But what actually happens is when it goes down, the motion isn't necessarily smooth, and when you release it, the motion up isn't necessarily smooth. It like oscillates a little bit. And because it oscillates, there's a state where the button is basically kinda pressed, kinda not pressed. And it oscillates a moment in that state. So what you see from an application perspective or a game perspective, is that what you see is that there are really fast changes, like millisecond changes basically, between press, not press, press, not press, press, not press, and then it stabilizes to not pressed. So this is good to ignore these bounces, and this is called debouncing basically. Yeah, and apart from that, everything else is basically just moving the gamepad around, where we can see there's this like global variable attached to the window object called gamepad position X, position Y, and if the action of a button, this is handle button function apparently. I do not remember the code. I am reading this code right now. So even though I like jump around, when I'm reversing this, I'm not really trying to understand everything which is working, like how it's working, because, well, I mean, this code is pretty easy, so I'm just jumping around English words basically here. Handle buttons, gamepad position, and I'm guessing there's like +1, -1. I wonder why is this like +10 here, which is kind of funny, and why is it 10? Do we have like 10 in the row? 10, I guess, characters? 5 characters, 6, 7, 8, 9, 10. Yeah, we have 10 in a row. Okay, oh, I know why it's +10 here. Because if we are at 0, like at this row, if we would do -1, then modulo in JavaScript, -1 modulo 10 in JavaScript, I think it's still -1. Or it might be, well, we can check it. That's not a huge issue. Let's just press this, and we do -1 modulo 10. What do we get? Yeah, we get -1. This is language dependent. Certain programming languages have it like this. Other programming languages would actually say, oh, it's 9. Like the result of that is 9. But JavaScript is not one of them, therefore we have to add this 10 here, which is kinda a nope normally, unless it's -1, because -1 plus 10 is 9, and then it's just like modulo 10, which is still 9. So we know now that if somebody would like be on J and actually press one more time right, then it would actually wrap back to A, which might be important or it might not be important depending on what are actually going to be the key presses, the button presses in the USB protocol which we see. So I think this is pretty clear. I'm going to keep this open because we might have to go back to it when we have decoded the protocol. And therefore, let's look at the protocol. What is the triple? Oh, sorry. So what I have turned on in my in Sublime is ligatures for the Fira code font. What it means is that, for example, if I inside JavaScript code, if I would write A is less than equal, then it changes these two signs, right? If I put them together, it changes them to like this magical looking sign, well, which is a normal math notation. It doesn't change the characters as they are written to the file. It just changes what's displayed to the user. This is how this font actually works. It's called Fira code. It's really cool. I know it's a little bit confusing, however, so I probably should have disabled it. Now, what this means is just like if I do spaces here, then you can see it's just like 3 equal signs, which means that it has to be. I believe the definition in JavaScript is something along the lines of it has to have an equal type and an equal value, because just 2 equals means. It has to have an equal value, but not necessarily the same type. So the types are kinda converted implicitly to whichever makes more sense. Okay, so with that being said, let's look at Wireshark. So I have Wireshark. Tell me if you can see this, or if I need to make the font a little bit bigger. How do I even make the font a little bit bigger in Wireshark? That's a good question. should be somewhere in view, right? Can zoom in and zoom out. Okay, let's try to zoom in. Oh, yeah, that works. Perfect. So what do we have in this file? We have a couple of get descriptor packets exchanged between the host and this device. I'm assuming that the device 3.7 is the gamepad. Now every USB device has usually multiple sub-devices. And usually the 0 is used for configuration with the host. And then, yeah, like whatever other sub-devices there are, they can do different things. And they actually have to, like, this configuration actually contains information about what does each sub-device do. If you look at a gamepad, right, there are like a couple of things there on such a gamepad. Well, first of all, you have the most important thing of a gamepad, which is buttons, joysticks, and D-pad, and so on, right? But that's not all, right? A modern gamepad commonly also has a microphone. So you have a sub-device for a microphone, which would be like, I don't know, maybe 3.7.2 or something like that, which is a different protocol, right? Because it's for sound, it's not for pressing buttons. And then also they have speakers, like these gamepads. So there might be another sub-device for a speaker. There might be also some other sub-devices on the gamepad, but yeah, like usually there are like at least 2 sub-devices, 0.0 for configuration, and then something else. So let's look at what is this, like what are we getting here. So first the host says to the device, it sends it a request, like get the descriptor, it's a request. Thankfully, we don't have to decode the USB packets, we will have to decode the protocol packets, however. And the device, the gamepad, responds with, oh, I am a device. Can I make it a little bit bigger? Yeah, and I am a DualSense wireless controller. So the device used for it, the gamepad used for it, was a PlayStation 5 DualSense wireless controller. Okay, and then it like says, okay, the host says, give me your configuration, and then the device responds with some basic, I guess, configuration, and then there's another request for configuration, and the other request has more information, and it has the interface descriptors, basically, like what are the interfaces, what are the sub-devices on this device. And we have this like audio interface, class audio. Then we have another audio interface, which I'm guessing is going to be, well, we have quite a lot of audio interfaces, honestly. Okay, and then what else do we have? This is all for audio configuration. Then we have HID. HID is human interface device, which means, yeah, this is the actual gamepad device, I'm guessing. And that's kinda it. So we have, yeah, like the microphone, I guess, and the speaker. This would be, one of them would be the microphone, the other would be a speaker, and we have the actual buttons, which is this HID device. So the HID will have an interface, the class is HID, and that would be the 3.7.4, which I'm kind of guessing. I think you have to add +1 to this interface descriptor number here. And I'm saying I'm kind of guessing because like this is the only thing we have in this file, so probably the author of the task, in this case, this was prepared by Dayan, he made sure that there's nothing distracting in the packet because it wouldn't be great for the player to lose time just like looking at some other packets. Sometimes you do that in CTF challenges when making them, but not in this case. In this case, we are given already all the interesting packets. Now the problem is that, as you can see, apart from the, if we have this like packet, right, with your URB interrupt in, which means that the gamepad actually sent an interrupt to the host with some data. This is probably because some action happened. I don't know, the joypad maybe moved a little bit, maybe somebody pushed a button, right? That's an interrupt. But modern gamepads are a little bit more, let's say, pro-gamer friendly, which means they are reporting their status almost all the time and many times per second, just to be a little bit more interactive. So you don't even have to touch the these like joypads, I guess, and because, well, just like moving the pad around a little bit, they are so sensitive that their position changes a little bit all the time, which means that, well, they will be reporting data all the time to the host, to the computer anyway, and as you can see, it is reported like a lot of times per second. I guess this time is every every 4 milliseconds we have a report, so that's what 250 times per second is the state of the gamepad reported, which is like a pretty decent refresh rate. Well, maybe not refresh rate, pretty decent report rate. Okay, so what do we have here? And this is where the problem kicks in, because the gamepad is reporting data, but Wireshark doesn't understand the DualShock PlayStation 5 protocol. This is the protocol, and I cannot like expand this section. It doesn't understand it. We just see it here, and that's about it. So we will have to parse it on our own, and we'll have to process it. So what I'm going therefore to do is I'm going to select all these URB packets, and now I'm going to export them. So I'm going to do File, Export Packets, and what do I want to export them as? I guess as JSON, because then I can interact with them in Python. Now, I'm not sure, let me switch the view here, because I have no idea in which secret... Oh, thankfully no secret directory was opened, only this gamepad directory, which is our work directory. So packets.json. You, by the way, don't need to do that. You can operate on the pickup file, no issues with that. The pickup ng format is, it's not super complicated, it's pretty easy, and if you would export it as pickup, that's even easier, that's way easier. So we want only selected packets, and we want, yeah, it should include the details, so cool, save. Okay, and it's creating this file, it takes a moment, and I don't believe we'll be needing Wireshark much more, because now we have this 75 megabyte file with the packets, right? Now, most of this data is really irrelevant to us. What we care about only is this USB HID data. So what we want to do probably at the beginning is just like process once this JSON file, get this HID data out of it, put it in some, I don't know, bytes or byte array or something like that, so decode it, and then store it in, I don't know, a pickle file or something which we can quickly reload, because parsing in Python a 72 megabyte JSON file takes a moment. Like, it will take maybe a few seconds, right? But if you're on a CTF, the last thing you want is like for every time you retry, like make changes in your script, and when you want to retry, you have to wait 3 seconds or 5 seconds for a JSON to load. As such, we need to write like some simple parsing right now, and let's call it maybe conf or like extract x.py. Okay, there we go. So what are we going to do? Where is it? It's in USB HID, and the USB HID is in the USB section. Is that true? No, it's not in the USB section, is it? Nope, that's not in the USB section. This is in the frame section, I believe, or even the layers section. Okay, so it's in the layers section, and the layers section is in the source section, right? Yeah, I think so. So, okay, so let's do it like this. We can actually, you know what, we are going to do it a little bit differently. Let's just run Python, import JSON. You know what, I'm going to write run IPython3. Import JSON. Then what I'm going to do is I'm going to open, and it's called, oh, I'm just going to maybe load it as data. So JSON load open, and the file is called packets.json. Yeah, around 1.5 seconds it took. So let's see, what is the type of D? It's a list. Okay, so D of 0 is this whole packet. Now we want to go to what are the keys there. the keys are, yeah, the source is what we are interested in. So let's go to source. Okay, and then in the source we have, what kind of keys we have here? We have layers. So that's layers, okay. And then we have this USB HID data. Okay, cool. Now we have to convert this from this Mac-like notation. I guess you don't see the full editor and the console. I don't think it matters much, but let's, rather it didn't matter yet, but let's change the window sizes so that you can see everything. And now what we can do is, oh, I have to even make it a little bit, I guess, smaller, like this. Yeah. See, I didn't stream for a while. So now that we have this, what we can do is we can replace the colons into nothing. So replace colon into nothing. And now we can just load it to a byte, and that's B, or rather bytes, from hex. And this is, well, hexadecimal, so perfect. Now we have something we can work with. So I'm going to copy this line into my editor. And now let's copy the other line where I just loaded the data, import JSON. But I want to do it on every, not only on D0, I want to do it on every packet. So for P in D, maybe, P as in packet, we do this, and this gives us the data back. So that's the maybe packet data, I don't know. Well, we can just call it P, I guess. And we can add it to a list of packets. So let's make a new list, which is called packets. Now it's a binary packet, and we can just append to it. So packets append P. There we go. And now let's save this to a file, but I'm going to do it with Pickle, because Pickle actually should support binary strings, well, binary bytes, which JSON doesn't. Like JSON just doesn't support this type. Now Pickle, remember never to unpickle untrusted pickles. Pickle is just a serialization format. It's actually a text/binary serialization format. Is pretty low level. Python uses it internally for certain things too. Oh no, actually it uses Marshall, but yet another one. So I'm sorry, I'm confusing things now. And anyway, what it can also do, it can create objects of any type. Therefore, if you have an untrusted pickle, somebody can create enough objects to actually spawn a shell on your device, a remote shell. So, or a reverse shell even, like it would just, no, a straight shell, like it would just connect somewhere. So yeah, careful with pickles, but because I'm creating this pickle, I trust it, so that's fine. So what we do is we do with open, and let's call it ASDF, p.pickle. I don't remember if it's a binary format, it might be. And that's pickle dump to F, we dump P. I don't remember if this is the correct order of parameters, actually. Let's do import pickle and do... What functions do we have there? We have quite a lot. We have dump, okay, and we do help pickle dump. It takes the objects and the file, so I actually mixed this up. Yeah, it's like this. Okay, cool. So let's run it. Python, is it called extract, I think? Yeah, okay, it took a moment. But now, as you can see, instead of this like packets, which is like 72-ish megabytes, we get a pickle which is way too small. Why is it so small? Why is it so small? Why are we so small? Oh, because I gave it a one packet instead of a lot of packets. So let's correct this little mistake, run it again. And now we have a pickle which has 1 megabyte, which will be just way faster to load for us. Which kind of means we can start with the actual solver, so let's call it solver py. And now we can import the pickle. Which KDE flavor this is? So this is Kubuntu. And it's I didn't change too much in the theme of it. Yes, the gamepad reports constantly, basically a modern gamepad. So, which is why they lose battery. Not super fast, but they do discharge. Like if you play actively, you actually need to recharge them almost every second day, I guess. So let's open that file which we just created. It's called, I just copy it, pipicle, but we want to open it as reading binary. Okay, and we do pickle load from a file, and we want our data back, and we just put data to maybe packets. So now 4 packets, 4 PN packets. For every packet, what we want to do is we want to just display it. Like for now, let's just display it. P, let's encode it hexadecimally without a separator maybe for now, and let's see what we get. Now with, wrong script, solver, yeah. Okay, so we got, let's make the console a little bit larger. We got a lot of packets, and as you can see, just like by looking at them, we can see that some stuff changes. A lot of stuff changes around here, actually, like quite a lot. No idea what's going on here. Now, what we have to remember is that half of this, no, I think like all of this data is actually already the HID data, HID data. Is that correct? When we look at here, yeah, this is already the USB HID data. So it doesn't contain the protocol, the USB protocol, which is good. Now this here and this here looks kinda like it's incrementing all the time, right? It has C3, C4, C5, C6, and so on. And it's incrementing, and yeah, and after reaching FF, it incremented here as well. So this is some counter, this is another counter, which we don't care about. Now, are we going to actually try to figure out the task based on this? We could, but that on a CTA would be a little bit of a waste of time. So instead what we are going to do is we are going to try to see if somebody already cracked basically this protocol for the gamepad for a dual sense. So it's PS5 dual sense, and what we care about is the USB protocol specification or reference, maybe something like that. And we don't want, and I guess we did say USB. We don't want the official one. Oh yeah, PC Gaming Wiki. Wiki usually in the name makes a lot of sense. So what do we have here? We have a link to technical documentation. Yes, please. Technical documentation. This is what I need. Okay. Can hide this. So let's look what we have here. We have descriptor. Oh, we actually already know. Oh, is it the descriptor we are looking for? Is it what we are looking for right now? That's the descriptor which we are looking for at the beginning. No, what we don't want the descriptor. What we want is what's being reported, and this is the input reports, I believe. Not Bluetooth, USB, so this is this. Okay, and we have a structure report in. It's a C structure, like C syntax. And that's Bluetooth. Okay. USB gets state data. There's report ID at the beginning, which is supposed to be 1. Is it 1 in our case? Let's make the console bigger again, so we get 1 row per packet. And yes, we have 0, 1 at the beginning, which is amazing. And then there's this USB get state structure. Tell me this is defined in this file. Yeah, it is. Okay, perfect. So apparently it's 63 bytes. I'm going to copy a whole line. Let's put it in an editor. How large is this line? 128 characters. And it's hexadecimal, so that's like 2 characters per byte. 128 by 2, it's 64, which is perfect. So this is the correct packet. I'm saying 64 because there's this like 1 at the beginning, which also we have to remember about. This is 1 byte, and then 63 bytes of whatever is this like this USB get state data. Okay, so what do we have here? We have the offsets here, which is pretty amazing. This is a good Wikipedia, well, wiki for this controller. This is a really good description. So we have a direction pad at byte number 7. So this is index 7 actually. The problem is that this is actually index 8, right? Because we have this. Oh, actually no. You know what? Let's do something like this. We have these packets, and now we have to. Let's close this because I'm just like forgetting to switch to solver. Let's just ignore the first byte. So I'm going to ignore the first byte, and now we have the offsets compatible to this. What we care about, oh yeah, sequence number. See, told you there's some counter there. What we want is we probably want this direction pad to be displayed. And then next to the direction pad we have 4 buttons. So okay, just this one byte, honestly, is everything we need to solve this challenge apparently. Because we have a direction pad which takes 4 bits, and then we have 1 bit per button. And hopefully these are the buttons. Maybe these buttons later in the next byte or next 2 bytes are actually the ones which are being used in this challenge, but we can figure it out as we go. So what we want to display, I guess, is like just show me this byte number 7, and you know what? You can show it as hexadecimal. And let's see what we get. Okay, we got 8s, a lot of 8s. That's a lot of 8. Oh yeah, wait. And then we have 48 here. So what's 48? Let's go back here and try to, you know what, I'm going to just copy this. Here, there we go. So okay, bits number 0 to 3 is the direction pad. Which means that if we have this, let's call it byte, then we have the D-pad is at B, and that's bytes 0 to 3, which is this mask. This actually is like this. I have 8 bits, right, in a byte, and I'm selecting which ones I want, and I want the first 4 ones, and that's the D-pad, the direction pad. How is it encoded? It's kind of weird. We'll figure it out. Okay, and then we have square. So maybe button square, that's bit number 4, is it? So let's just shift this by 4 and grab 1 bit. And let's do the same for cross, circle, triangle, and let's update this. Okay, and now we can actually print what's going on here. So I don't know still what this D-pad thing is. Like, how is it encoded? We'll have to figure that one out. D-pad, okay. And then we just have the buttons, so let's do them in order. Button CI, button TR. Okay, and let's see what we get. Okay, so nothing is pressed. I'm scrolling up all the time. I know it can. Oh, and here we have the 3rd button pressed, and the 3rd button is circle. So circle was pressed. Okay, and then yeah. So as you can see, when a circle is pressed, right, we have quite a lot of packets when the user is holding this button. So we will have to do a little bit of a deduplication. However, the good thing is that there isn't an alteration here, alternating between 1 0 1 0 1 0, as in like maybe that the bouncing on this gamepad wasn't really needed. Okay. Oh, and let's see here. There's some change between 8 and 2. What does this mean? What is it? What is 8? Is it described somewhere here? There's some enums here. Direction. There we go. So this is what I need. Direction, description, what is what. When will I make OSDev part 2? It will come out after ray tracing. And this is actually an internal joke on the Polish in the Polish community, because both the series related to OSDev and ray tracing are kind of stopped indefinitely. but people still ask about it, and I always answer like this, but the one will be after the hour. What's the goal of this challenge? So the final goal is to figure out what, having this keyboard, or rather this flag entry utility, what did somebody press on the gamepad to select which characters on this on-screen keyboard, and if they can with a gamepad select a character, press a button, and then the character appears here, and somebody entered with a gamepad the flag, and what we have is we have these low-level USB captured protocol of entering this flag, and we have to figure out how did somebody move over the screen keyboard and what did they actually press. Okay, so if you don't know how enums work, it's just like you start from 0, and then every other name is actually the next number, next ordinal number, I guess. So someone pressed 2, and that means east. Really, you're making me think. What does east mean? That means right. Okay, so east is right. So, okay, so now we know that somebody pressed right here. Yeah, and what is 8? Sorry, 8 is none. Okay, that's good. So nothing was pressed, then somebody pressed right. And this is just one press, by the way. This isn't like multiple presses. This is just one press, which is being reported over the span of, I don't know, how many, 20 milliseconds maybe? Maybe a little bit more, maybe like 50 milliseconds. And then somebody released it. Which is cool. So what we have to do now is we have to kind of deduplicate it, right? And see how many times somebody pressed right, and then a circle. And to do that, what I'm a little bit worried about also is that we will run into this problem of the bouncing, but we will have to do the bouncing. But let's operate under an assumption that we don't have to do the bouncing, and what we have to really do in that case is just the duplication. So let's do the duplication first. And the duplication in this case should be really easy, actually, because what we can do is we can put all of, well, it's going actually to be even easier than I thought. We start with previous, and that's going to be the previous thing which was pressed. And at the beginning is just like packets of whatever is the first packet, that's going to be the first state. I don't imagine anyone, like, you know, mashed in the first 4 milliseconds a button after connecting a gamepad. I don't think that happened. Therefore, I'm just going to assume that the first packet is just like nothing is being held. So packets 0, and I'm actually grabbing the 8th byte, and this is going to be the previous. Now, if it changes, then I'm interested in it. So to do that, here, if B is not previous, not the same as previous, then we want to do all of this. And at the same time, we want to say that actually previous is what B is now. And I only care about this 1 byte. So let's see if it worked. Yeah, it worked. Now we have it deduplicated. You know what? I'm going to do clear at the beginning. Clear. Okay. And now I can scroll to the top of the console, and this is the beginning. So, okay. Somebody pressed right, released it, right, release, right, release, right, release, right, release, right, release, and so on. And then pressed 1. So how many times did somebody press this? 1, 2, 3, 4, 5, 6, 7. So 7 times. Let's look at the application. 1, 2, 3, 4, 5, 6, 7. Oh, no, sorry. 1 from here. 1, 2, because it was here at the beginning. So first press, second, third, fourth, fifth, sixth, and 7th. So we are at H, which makes sense because if we go back to the description of the challenge, the flag format is hackArcana, so we expect hex at the beginning. Okay, so yeah, this kind of seems to work. So what we have to do now is we basically have to, I guess, get this keyboard. I'm just going to, like, you know what, select this keyboard and copy it and see what happens. Maybe I can kind of get away with just easily translating it. So my keyboard, that didn't work. Okay, we said is like 10 in every row, right? So is this 10? No, that's 11. J. Yeah, okay, J, T. So this is going to be the keyboard in that case. Keyboard is, and let's make a list of strings maybe. Okay, and now we also have the position at the beginning. So XY, okay, it's 0, 0. Like this is where we start with, as we can see in the application. Okay, then what we do now is every time somebody, so yeah, let's look at this. We have this, we don't need to print it anymore, I believe. What we can do is like, if the value is actually just 8 and nothing is pressed, we can kind of ignore it. So here, let's start with noting the previous here. And now if B is just 8, we don't really care. Let's continue, because that means everything is released. Otherwise, we actually kind of want to know what happens. So if dpad is equal to, and let's go through this. If it's equal to 2, then we know we go right. And what does going right mean? That means that x is equal to x plus 1 modulo 10. This is what we saw in the JavaScript application when we were reverse engineering it, but it was like basically this behavior. Now let's see what happens if we do -1 modulo 10 in Python. Yeah, and as you can see, in JavaScript it was -1, but in Python it's, no, you cannot see, but in Python it's actually, in Python is actually 9. So, which is cool, because that means I don't have to do, when moving left, I don't have to do this +10. Okay, you're missing, sorry, I'm missing what, a comma? No, it's here. I think I have everything, honestly. Oh, you mean like, but if you mean that characters are missing on this list, that makes absolute sense, because not all characters were needed to enter the flag for this challenge, which is fine. And yeah, otherwise, it seems this keyboard is actually copied correctly, or entered correctly. Cool, so now we continue. I hope nobody, well actually, you know what, I'm not going to continue. Let's just do it like this. L if dpad is equal, what's left? Left is west 6. Then x is equal to -1. Yeah, we just move it left. If dpad is up was north, right? That was 0. So if it's 0, then we do the same with like this, but with y. And if it's south, that's 4. This is 4. We do the same, but with a plus sign here. So now we are moving around this keyboard. If it's anything else, like the dpad has a different value, then we panic. We do assert false. Dpad has a weird value. Which, it might still be 8, right? It might be 8 if somebody pushed a button. So let's do L if it's dpad is 8, then we actually just like pass, we don't have to do anything. And now let's see if somebody pushed any buttons. So actually, let's look at the output again. Does anyone press anything else than the circle? Circle, no, only the circle apparently is pressed. So let's do it like this, assert that all the other buttons, which is the square, are 0. So that we know if we get notified when something is not wrong. Like, sorry, something is pressed, which we didn't expect. Otherwise, if the circle button is pressed, then we want to add the character we are currently on to the flag. So the flag is going to be empty at the beginning, but now to the flag we add the character which from the keyboard, and we need to do now the XY mapping to this keyboard. So it's going to be actually pretty easy. It's like X plus Y times what's the size of a row, and the size of a row is 10. Here I have a mistake, obviously, because there are not 10 rows of this keyboard, just 6 of them. So here I need 6. Oh yeah, sorry, I need commas as a separator. Thank you very much, Adrian, for pointing this out. I misunderstood. Oh, wait, so... Okay. I can do it like this. I don't need really this to be a list, because I already implemented this mapping to 2 dimensions to 1 dimension mapping. And now when I have this, I can, I guess, like print the flag every time with every addition, so I just know it works. And let's run it. And I need to move this again. I don't need to clear anymore, I think. And it says what's dpath. I don't know what's dpath also. It's dpath probably. It doesn't know what's button CR. No, it's an assertion error. What, somebody pressed CR? Really? Oh, that's CR is what? It's cross. Why did somebody press cross? Where is cross pressed? Which button is it even? So cross is the second button. When is it pressed actually? Or did I make the assertion incorrect? I don't see it being anything else than 0. Nah, here it is. There we go. Yeah, somebody really pressed cross. So I'm guessing if we go to JavaScript again, the cross is this reset, which resets the position. I think this is it, and we need to implement it in that case. So if somebody presses cross, so if the cross is pressed, then we actually have to do XY is 0, 0 again. And let's comment this out. Okay. Okay. This is why you put assers, because otherwise it would just like break everything. Yeah, this didn't work. Why didn't it work? Let's do it like this. Every time something actually happens, we actually print it. So, and let's walk through this. So from the beginning, we have 2, 2, 2, 2, 2, 2, and it's still on A. Why is it on A? We have moved, like, the D-pad should have moved a lot of times. Did it move? Print up, moved right. Okay. Yeah, well, it does understand this. Is my formula wrong in that case? Moved, moved, moved. Okay, if it moved, then I actually want to see the position of it. You know what? I'm going to just print the position of it at the beginning here, or rather maybe let's do pause and here do XY. You are writing on chat, which kind of might mean that you spotted the error, but I want to find it myself. Okay, so the position works, but oh, wait. I maybe mixed up the what is what. Let's reverse the buttons, like what they mean. Okay. And if we reversed the buttons, what they mean, nothing happened because, wait. Okay, so this is H in that case. Yeah, cool. And then it reset. And then it reset again. And again. No, it doesn't. This makes little sense. It's like somebody... No, I don't think this is correct. This looks a little bit weird to me. I think this has to be a reset. Let's look at the... Assume this is not a reset, and what's... Oh no, I know what happened. Somebody by accident, this is not a reset, intentional reset. Somebody pressed a button by accident, the wrong button, when entering the flag. So it doesn't mean anything, it's just the wrong button. Let's try it this way. Yeah, there we go. There we go. Okay, that was a nice red herring. But it was pretty easy to figure out, actually, that somebody just, you know, fat-fingered. Which is just a cool thing in this channel, actually. Okay, so the flag is MNK forever. Mouse and keyboards forever. As somebody who tried learning FPS games on a Gamepad, like competitive FPS games. Yeah, I'm sticking with mouse and keyboard as well. So yeah, that's it for this task. Actually, now if I would have an account, I would just enter it here. But because I don't want to influence the scoreboard, I didn't create an account here, so I'm not going to. Yeah, I'm not going to enter any flags. I think that's it. I'm going to look through the chat list if we have any questions. But I think I answered everything. Okay, I see there are some anti-fans of ligatures. Yeah, I will disable it because I actually ran into this situation recently when doing an introduction to programming webinar, basically, and I confused beginners with ligatures because they tried entering them, like finding them in Unicode and entering them, which is honestly a correct thing to do if you don't know it's a ligature. So yeah, but that obviously didn't work. So I'm just going to disable them, I think. I don't have on this computer there are like a couple of, I think, like 4 options which you have to put in Sublime to disable it. So I'll just do it off stream. When is the next stream? Good question. Probably next week, I guess. I want to still do push a video on this week. It's going to be, I have like 2 articles in Paged Out, which I've written. I wanted to just go through them on the live stream. I've written the, let's open the issue again. How many downloads do we even have now? 67,000. This is going fast. Yeah, like people like this issue, honestly, and I'm happy about that. Like the team which you can find here, like put a lot of effort into this issue. And the authors as well, obviously. We have the like largest amount of articles ever for Paged Out. So I've written together with Mateusz Jurczyk from Dragon Sector of this article, which I already showed, which is the hacking the worst laptop ever made, which is actually a pretty funny story. We went with Juru, with Mateusz, to Zurich Vintage Computer Festival, and they usually have like challenges there. As in, don't think about CTF challenges, they are usually easier. But this one apparently wasn't easier. It was like find an O-day in this netbook. And yeah, we spent like 4 hours, I think, there until they closed for the day, trying to get a shell, or rather a terminal, on this laptop, which was running a modified Linux. And we did get code execution as root. Well, everything ran as root, but we did get code execution. We didn't get a terminal because we couldn't find it on the file system. I don't think there was one. Yeah, so I want to go through this article, and if we go back to the menu, the table of content, just I think on the 3rd page. Oh, Command Chrome, don't give up. There we go. Then there's another article I've written somewhere. Where is it? I think it's in programming. Yeah, it's in programming. It's kind of funny because I like when doing the training, the mastering binary files and protocols training, which starts, by the way, next week, the next edition. If you're interested and you would like to sign up, then I noticed that this pattern, like n divided by 255, has a really interesting bit pattern when looking at it in grayscale. And the article is basically about it, about like floats which look like this when you put them next to each other, which have like really repeating bit patterns. Nothing huge, but it's cute. It's a cute trick. I kinda like it. Yeah, there are like so many different articles and amazing articles in this issue. Just go and read them. And I guess the last thing I wanted to... sorry, looking at the chat. Okay. I'm seeing CTFs from your collection. Would you be kind enough to show us your collection of CTFs? I'm not sure what you mean by a collection of CTFs, but so it's like this. We are working slowly to put more and more challenges from which I made on this website, which will be again from Dragon CTF and Google CTF. Google CTF ones are available on, like, if you go to Google CTF's GitHub, the majority of challenges has been open sourced under Apache tool license, if I remember correctly. You would have to check that out. This includes also my challenges. And for now, we only published here challenges which have downloadables. As in, like, don't have a server side. We will be working slowly to get the server side ones as well running. Now, I'm not sure what you mean by a CTF collection. What I do have somewhere, but I would have to prepare that, is I have a large collection of screenshots from scoreboards from CTFs I played. Not all of them, but a lot of them, actually, a lot of them, especially when we played the first 2 years as Dragon Sector. So there are some cool screenshots from some pretty cool CTFs. We can go through them at some point. Yeah, I think that's it. By the way, one thing which I'm trying to do, but I'm not always successful, is if there is an article which I'm writing, I'm trying to include also CTF-like exercises in each article. So, like, there's an article about, this is like a theory article, basically, like, why do we even get exercises? Like, what's the underlying reason? And then there's this exercise, which is like, you can just go to it, and yeah, like, there's basically, how would HTML look if it would be encoded in binary? And there's this binary protocol, and you would have to, you get a file, and according to this protocol, you have to write a parser, blah, blah, blah. You get the flag at the end, and you just submit it and get points for it. So yeah, we're trying to, like, put, in every article, you're trying to put a challenge. Not every article right now has it. I think half of them have it. But yeah, it's kind of the goal is that every article at some day will actually have, like, 1 or 2 challenges, like CTF-like challenges associated with it. Okay, I think that's it for today. So one last thing is, like, again, I'm running this workshop it starts next week, but it goes from April 8th until late May. It's 14 meetings, 50 hours, and it gets you from, I have no idea what's a hex editor, and I have no idea what you just did with this binary protocol, to, I don't really need a documentation to reverse engineer a protocol or a binary file format. I just know how to do it, right? In 50 hours, and a lot of exercises were, like, a lot of CTF-like exercises connected to this. If you're interested, go to hackArcana.com and just in workshops. It's there, and I think in the description of this video we should have a discount code as well. If we don't, I think we do, but if we don't, you can look around. The discount codes are available here and there on various of our social media. And in PageOut as well, I think. There's an advertisement somewhere. And I'm saying somewhere in PageOut because the PageOut actually has randomized advertisement positions. So every time you download, every time you download with 2 minutes to let the cache clear, you get ads on different positions. Something our sponsors requested at some point. They requested a solution to a problem, and this is what we provided. Cool, that's it for the day in that case. So thank you very much, people, for being here with me. 50 people, that's not bad for a live stream, which on a pretty much channel which we are resurrecting and unearthing. So thank you for being here. I wish you a pleasant evening, and see you next week, basically. Take care, bye-bye, and thank you. And thank you to my moderators again for being here. All right, we have a discount code on the last slide.